Okay, you're all welcome to this video. This is number 10 question of 2011 May-June physics exams. Okay, so 10A here says, what is a vector quantity? A vector quantity is a quantity that has both magnitude and direction. Okay, so magnitude and direction, right? That's a vector quantity. Okay, and the next question says 3 vectors, 3 meter per second north 45 degree west, 12 meter per second west, and 5 meter per second south act at a point. I sketch a vector diagram to illustrate this given information. I don't think this is a problem. So first of all, let's see our coordinates. Okay, then we have the first one is 3 meter per second. This is 3 meter per second and is between the north and the west, and is 45 degrees, right? This is 45 degrees northwest. That means here is also 45 degrees, right? Because this is 90. So if here is 45, here is also 45. Then the other one is 12 meter per second west. So this is 12 meter per second. And while the other one is 5 meter per second south. So this is 5 meter per second, right? So this is exactly what we have. This is the diagram we are asked to draw based on this question. Sketch the vector diagram to illustrate the given information. Now the second one says calculate the resultant of the vectors. Now to find the resultant of the vectors, first of all you must know what we call the horizontal component, and secondly you must know what we call the vertical component of each of the vectors. Okay, for example, this vector here is vertical 5, so I'm going to write it here, but just that it's going to have a minus sign. It's having a negative sign because this is in the negative y-axis. Here is positive y-axis, here is negative, here is positive x-axis, here is negative x-axis. Okay, then this one here is already on the x-axis here, okay, but negative x-axis. So I'm going to come here and write minus 12. It's already on the horizontal component. Then this one here is partially on the horizontal and partially on the vertical. Okay, so in that case now it means that I can resolve this to the horizontal. I can also resolve it to the vertical. The horizontal component of this is 3 cos 45, and it's going to be negative because it is negative x-axis. It will resolve to a negative x-axis. For this one, the vertical component is 3 sin 45, but in this case it's going to be positive because this is the positive. You are resolving to the positive y-axis. So let's add this and see. Okay, I'm going to use my calculator here and add this. So we have negative 12 minus 3 cos 45. So this is going to give us sorry, I made a mistake. So this is going to give us negative 14.12. okay, while the next one you have negative 5 plus 3 sin 45. So this is negative or minus 2.88. okay, so the resultant vector is going to be square root of the square of each of them. That means minus 14.12 squared plus minus 2.88 squared. Okay, and that is going to give us okay, so this is going to give us 14.4 newtons. You see, life is beautiful at this point. Now the next thing we are going to look at is the direction, because once you're asked to find the resultant of a force, it's important you also know the direction. The direction of this force theta is given as tan inverse of the vertical component over the horizontal component. Okay, now in doing this calculation, don't worry about the negative sign. We are going to deal with it later, but we can just quickly say tan inverse of 14.12 divided by 2.88. okay, let me do that quickly. Tan inverse of 14.12 divided by 2.88. Now you don't have to do it directly. You don't have to, sorry, tan inverse of that's a mistake, please. The vertical component is 2.88, horizontal component is 14.12. So that should be 2.88 divided by 14.12. Okay, I think we should divide this first. So 2.88 divided by 14.12 is giving us 0.204 approximately. So now tan inverse of 0.204 is 11.53. So this is 11.53 degrees. Now, but we can't conclude here because of this negative sign. The negative sign here, x is negative, y is negative, means that the resultant is between negative x-axis and negative y-axis. Yes. So that means the 11.53 is here. That's where it is. That's where the 11.53 is here. So this is west-south, which we can say west 11.53 degrees south. Or you can subtract from 90 to switch it. That means it's going to be south 90 minus 11.53, 78.47 west. You see? So you can either say west 11.53 degrees south, or you say south, which is here now, which is from south to west, south 78.47 degree west. Okay, so that's the answer to that question. Now that leads us to the next one. It says in the laboratory experiment, that is C, to determine the force constant of a spring, the mass or the spring, okay, the mass of the spring, this is correct, this is off. The mass of the spring was varied and the corresponding extensions were measured and recorded as shown below. We have the mass given in grams, and this is what we have. We asked, this is the weight, and this is the extension in centimeter. This is what we have, right? And we asked to copy and complete the table. Now, to convert mass in grams to weight in newtons, first of all, the mass in gram, you need to divide it by 1000, then multiplied by the acceleration due to gravity, because weight is equal to mass times acceleration due to gravity, so you must multiply by 10. So you divide by 1000, then multiply by 10. So by the time you do this, it means to divide by 100. Okay, so if I divide this by 100, I'm going to get the weight. I hope you understand that. So, or you say 50 divided by 1000 times 10. When you say 50 divided by 1000 times 10, is the same thing as saying divide 50 by 100. I hope that makes sense. So 50 divided by 100 is 0.5. 100 divided by 100 is 1. 150 divided by 100 is 1.5. 200 divided by 100 is 2, or 2.0. Let's make it to one decimal place. Then 250 divided by 100 is 2.5. Okay, right? If it is to one decimal place. Now the next question, we have answered this question. Now graph questions are the easiest. Prepare to answer graph questions. They are easier. You don't need to think much. Now the next one says plot the graph of weight W on the vertical axis and extension on the horizontal axis. Okay, I want you to notice something, that extension here is given in centimeter, so I can choose to make it meters, and I'm going to show you how to do that. But in order to plot this graph, let's go. I have a rough graph here. My work is going to be rough, but follow through. Now since both x and y are positive, so I'm going to put my vertical axis somewhere here, very close to here. Then my horizontal axis somewhere here, right? Very important. And the next is let's see, this is 0.51, 1.52. So here we can 0.51, 1.52. Okay, we can do that. We can use 2 centimeter to represent 0.5 units. That means at every point you add 0.5. That means here will be 1.0, then here will be 1.5, here is 2.0, and here is 2.5, right? Okay, then I can write here that W is newtons, right? Yeah. Then for the next one is extension. Based on what I can see here, from 6 to 5, I can use 5, 10, 15. So 2 centimeter represents I can use 5, 10, 15, 20, 25, 30, and so on, 35, right? And here I can write E centimeter. Now it's either you say E centimeter or you say E times 10 raised to the power minus 2 meters, because centimeter is 10 to the power minus 2 meters. Please don't forget that. Okay, that's very important. Yeah, because this is the SI unit. Now in terms of plotting the graph, like I said, my graph is not straight. You use a ruler to make sure your work is neat, right? I'm just showing you how to go about this. Now when the weight is 0.5, extension is 6.5. I also want to say this, that you can know what each of these represents, like this, each grid lines. Okay, we have 10 grid lines before 5. So but before then, here should be 2 centimeter represent 5 units, okay, on x-axis. Then you can say 2 centimeter represents 0.5 units, okay, on y-axis. Okay, you should do that. So coming back here, 0.5 and 6, yes. So I was saying that to know the value of each grid line, divide 5 by 10. Since you have 10 grid lines before you get to 5, if you count, you have 10 before you get to 5. So that will be 0.5, meaning that each grid line represents 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.55, you see? Or you can multiply by 2 to get 1. That means every 2 grid line will mark 1. So after 2 grid line, 1, 2, another 2 grid line, 3, 4, 5. You see, I prefer using that, it's faster. So when you say 0.5 and 6.5, this is 0.5 for W. 6.5 is after 3 lines, 3 grid lines. 2 is 6, so you add 1 more to make it 3. So somewhere here, right? Then the next one is 1.0 is 11. So 1.0, 11. So 11 is somewhere here. Okay. Then the next one is 1.5, 15. So I have 1.5, this is 15 here. Okay. Then the next one is 2.0, 20. So I'm going to have, this is 2.0, 20 is somewhere here, right? Then we have 2.5, 25. So this is 2.5, then here 25. So we can mark it this way. 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 And we can mark this way. Then we draw a straight line, you know. My line may not be very straight, but you know, whatever it is, you know, yours should be straight. So we have answered this question here, which says we should plot the graph W on the vertical axis and extension E on the horizontal axis. The next question says, using the graph, determine the force constant of the spring. So this is the graph. You can find force constant by plotting, you know, F is supposed to be equal to KE. That's the formula. So that means if you plot a graph of F against E, your K here is going to be the slope. So to find the force constant, it means the slope of this graph. So I can come this way, trace here, down here, to this point, to this point. Okay. Here means the x-axis is 20, the y-axis is 2.0, and here means that the x-axis, if I trace it, is 11, and the y-axis is 1.0. So I can, my slope is supposed to be equal to the change in y over change in x. So that's y, or you say y2 minus y1 or over x2 minus x1. So that's going to be 2.0 minus 1.0. That's for the weight. Then divided by, this one is going to be 20 minus 11. Now, but this denominator, I'm going to, you know, multiply it by 10 to the power minus 2. Remember that the extension here is 10 to the power minus 2 if it must be in meters. So 2.0 minus 1.0 is 1. 20 minus 11 is 9. So this is 9 times 10 to the power minus 2. So let's see what 11, 1 divided by 1 divided by 9 times 10 to the power minus 2. Okay, that is giving me 11.11. So 11.11. Okay, so I think that makes a lot of sense, which means that this is 11.11 newtons per meter. That's the answer. That's the slope. That's the spring constant. Quite easy, isn't it? Now, the next question says, determine the natural length of the spring if its length was 25 centimeters when the load is 250 meters. When the load when loaded with 250 grams. I think that's quite easy, because to determine natural length, remember that extension is supposed to be original length minus the natural length, right? And if you look at here, for 250 grams mass, the extension was 25 centimeters. Okay, so I'm going to say extension here is 25 centimeters, equal to the new length is 38 minus the natural length. We don't know what it is. So by the time we check, you are going to see that the natural length is going to be 38 minus 25, and that's going to give us 13 centimeters. So that is the answer to that question, right? Quite interesting. Okay, so see you in my next video.